Hello. Uh, so if you have any doubt regarding the past week content or assignment, you can unmute and ask. I think everyone, I think the people who wanted to join have already joined. So, uh, what is question? So kindly explain the sliding window protocol by taking the image as a reference. Okay. Um, okay. What is the content in this week's material? Uh, week 4, right? Transport layer performance, buffer management, congestion control, transport layer primitive, transport control protocol basic, transmission control. Yeah. Uh, Give me a second. Let me just connect uh, my tablet, the meeting, so that I can draw. Okay. So yeah, could you send the image again so that I can download it again? Okay. So yeah, my screen is visible. Okay. So his doubt is to explain the sliding window protocol by taking the reference of this image. Okay. So can anyone tell me like where this sliding window thing is used? Like in which layer? Transport layer. Perfect. So it's not in week four's content. It was in week three's content, right? The transport layer thing. Yes. So yeah, perfect. So the thing is that so I talked about the window thing last time. So if you go to week three, so I talked about there is a window. There is a certain window here. I mentioned there's a certain window in the sender side as well as in the receiver side, and you can send packets so that your window will not be full. It's kind of like that. But in this case, the thing is that let's say like you have all these packets. So you have let's say you have seven sequence numbers, 0, 1. So I actually didn't go through the lecture videos because we don't the tutors don't really go through the entire week's video. But I'm just assuming that this is the assumption. Okay. So there are, let's say the window size is 8 and the packets that it is sending is 0, 1, 2, 3, 4, 5, 6, and 7. Total of 8 packets is there. Okay. So, and let's say like, this is a range of sequence number. Range of sequence number. So if you joined the last live session, you must have noticed that how I opened up the white circ and how I showed the communication between the two hosts and how they generated the random initial sequence number RISN and how they transferred the packets across the different hosts and different receivers. So if you have done that, so I am assuming you must have went to the materials. If you have done that, you must have known that there is a limit to the sequence number. So also, like in computer, there is certain range, like 0 to some million or billion range. The numbers can be represented in a computer system. But what happens that after these numbers are done, like after all these numbers are exhausted, so it will be repeated again from 0 to n, okay, and so on. This is called, and the time needed to exhaust all this thing is measured by something called timeout timer. The timeout timer, okay. But anyway, so this is another extra bit of information. But the thing that what I was trying to tell is that here, since it is having this number from 0 to 7, the range of number is assumed to have till 7. Okay. Okay, the range of sequence number is till 7. Okay. And so, but the window size is 7. So, but window size equal to 7. Sorry. Window size is 7. So when window size is 7 and when window size is 7 and your range of sequence number is 0 to 7, then what happens is that, so yeah, so then, so come to the first setting in 0 to 6. So this is the window size. So it will maintain that window size, and the window, what it does, it just slides. The window slides. Okay. So when the window will be sliding, the window will be sliding when it will get the acknowledgement for the packet. So in a TCP connection, as I said last time, in a TCP connection, first is connection establishment. Then data transfer. Third में connection termination. So this data transfer phase is going on here. So connection is established. So in the data transfer phase, since the TCP is a reliable connection, connection full protocol, each packet it sent, it must get a acknowledgement. Okay, because if you are sending a packet, there might be chance that the packet will be missed or like delayed or got lost in the network. So it should get acknowledgement. If it is not getting the acknowledgement, that means the packet hasn't reached. So the source will send the packet again. Okay. So here the window size is 7. So it sent the first packet, frame 0. First frame, we'll use the term frame because there's a term we use in the transport layer. So it sent the first packet. In the next, so while we are waiting for the acknowledgement for the frame 0, and we'll stay in the same window, we'll send the frame number 1. Okay. Frame number 1. Meanwhile, also we'll send the similarly, we'll send the frame number 2. Meanwhile, we'll get a acknowledgement for packet 0. Okay, so once we get the acknowledgement from packet 0, we'll not send anything, but we'll just update the window because we know that now packet 0 has already reached the destination. We don't need to send it. So we'll move the window a bit, and then we'll send packet number 3 or the frame number 3. After that, we'll get receive, here it is receiving the acknowledgement number 1, packet number 1. So we need to move the window again, because 0 and 1 are already moved. We don't need to worry about them again, because they are already sent, and it is already received by the by your what, uh, uh, the receiver. Okay. Yeah. So yeah. So, and the next we're sending the frame number 4, and we're keeping the window like this. This is the server side thing, or the sorry, this is the client side thing, sender side thing. In the receiver side, it also maintain a window. Okay. So if you see here, it is maintaining one window, 0. Why it is maintaining one window? Why it is maintaining one window? The reason it is maintaining one window, because sometime this acknowledgement might get lost in between. Okay. So let's look at a scenario. The first, that we are sending packet number 0, and it got lost in between. So if you have the packet number 0 in the window, okay, 3, 4, let's say total number size is 5. Okay, it's lost, but again you send packet number 1, it went. You send packet number 2, it went. Okay, and you are getting acknowledgement for packet number 1, and you are getting acknowledgement packet number 2. Okay, so when you see, after a while, there will be a timer. After a while, you are getting you are sending packet number 3, and you are getting acknowledgement number 3, and you're not, since you have not got acknowledgement packet 0, that means that packet 0 has already lost in the network. So what you will do is that you will select this packet, and you will send it again. The reason you could do that, because your window is holding this 0. What is window? Window is just a memory location, or you can say, in a Python programming language, you can say window client side equals to a list 0, 1, 2, 3, 4. Okay, or a set, you can say. Once you got a acknowledgement, you can, in a program, you can write it like this: if ACK is received, then window client dot pop ACK I, let's say that I. You can pop that. If you got the acknowledgement for packet 0, you just pop that. I mean, you just remove that from the window. So you don't you don't do that in the middle. So you wait for the packet number 0, and then you pop it out and move the window like this. The next number you add it. Okay. So it's kind of like that. Programmatically, it's kind of like that. Okay. So this is the role of window in the server side. So what about the window in the receiver side? Okay. So there is also a window in the receiver side as well. I was telling. So let's say acknowledgement get lost sometime. So this is packet loss. There is something called acknowledgement loss. Okay. So let's say you have like this. You're sending packet 0. You received acknowledgement for packet 0. Okay. So in your window, you have 0, 1, 2, 3, 4, and here you kept 0. Okay. Then let's say you sent 1. Okay. And when it receives 1, it will maintain that in the window as well. 0, 1 now. Okay. So here it got already 0. So it will move the window forward and it will keep 0 outside. 2, 3, 4, 5. Okay. So now let's say this acknowledgement in between got lost. Somehow got lost. Okay.
Huh? The security go away.
Okay. So if the acknowledgement is lost in between, so if the acknowledgement is lost in between, what it will do is that so this will not now you will. So if you look at this scenario now, you will not receive any acknowledgement in this side, right? In this side, you'll not get you'll not get any acknowledgement. So then you pass packet number 1 because it is in the window. It will sorry packet number 2. Okay, and let's say you got the acknowledgement for packet number yeah. So when how this sliding windows move? Yeah, so you'll get the yeah, you will get the 2. Okay, so so here once this once this zeros acknowledgement reach in the source again, their acknowledgement, so 0 will be removed from the window. 1, only 1 will be there. Okay, and once acknowledgement is lost, okay, so this acknowledgement will not reach here. So it will not reach here. So you'll get 2 and you will send back 2's acknowledgement. 1, 2. Okay. He'll get 2's acknowledgement. So since 1's acknowledgement has not been reached yet, so we cannot remove 1 from the window. So it will wait for certain time. Okay, it will wait for certain time, and if it doesn't get if the once acknowledgement doesn't reach, so there might be many things like it might be delayed somehow here. There will be some traffic in the internet. It might get delayed. Also, it might get lost in between. So if that happens, then if it is delayed, so it will wait for some time. After a few time, if this is delayed, so it will give it a chance to reach the destination. But if it doesn't reach the destination after a while as well, then it is considered as it is lost in between. So it will send the acknowledgement for packet number 1. Okay. So the reason it is keeping it in window is that if it is in window, it can then only it can send the packets acknowledgement. Otherwise, it will not send the packets acknowledgement to the it will not be able to send the packet acknowledgement to the client. So that's why we're maintaining the window in the both side. So 1 second. Okay, so that's why we're maintaining the window size in the both the direction. So yeah, so I think you might got your answer, but yeah. So if there anything else in doubt, so you can ask me now. What do you mean by port? I'll explain what do you mean by port, but uh, I think yeah, I'll explain the ports, but I think it was covered in week one, so you can watch the videos for week one. So ports, yeah, the ports. So ports are like I'll just explain this shortly. If there is a computer and and there are multiple computers. Let's think about your school or college network. So here is a router, or it's your home, let's say, and this is your internet. So the traffic is going to each computer. Okay, it's going and coming. Now, if you look at one computer, uh, there is a multiple of application is running. Like there is Chrome, there is your Zoom, your mail client, and FTP servers, and so on. So when this wire is coming here, let's name this wire as, let's say, W. This wire is coming here, W. It is containing traffic for Chrome, TC, then traffic for Zoom, let's say TJ, traffic for mail, let's say TM, and traffic for FTP file, so let's say TF. Where it will reach this point, to go to Chrome, go to Zoom, go to mail client and go to FTP server, TC, TZ, TM, TF. We need to we need to send all these things differently to the different service. That's why we use port. So port is a virtual number that is given, that is there in the computer. It's not like the physical port that you use. So Chrome will be using port 80, let's say. Mail server will be using, let's say, 4010, and so on. So they are like virtual thing to just distribute the traffic across different ports. Did you get the idea? Hello, did you get the idea? It means that port is something root number where from we can uh, separate particular connection and transfer data separately. So you don't have to separate them. So it's already separated. So if there is a HTTP connection, it will go through port 80. If it is a HTTPS connection, it will go through port something, port T or something, 40 something. So it's already separated, So based on the service that you run, uh, it will based on the service that you run, the ports will be automatically assigned. And there are some uh, there are some open ports you can use for your own experiment. But yeah, there are some ports you can use for yourself if you want, but mainly uh, it's like that. So put to me every protocol using their decided port for transferring data. Don't send direct messages. Send in the group so that everyone will know that you're asking the question and this is the question. Don't just send in the direct messages. It's not good. Okay. Anyway, yeah. Yeah, I think your doubt is clarified properly. We can move to week four's content. The tutorial session will not be long today, so I'll try to cover it up with some other things. But uh, yeah, mm, window size. So there, I didn't actually make any slides or something for this week's content, but I'll try to go through 10 pixel proper congestion management. Shivpal. Okay.
हेलो
Yes.
जी सर वन क्वेश्चन सर दिस सेशन हेलो आई एम
Yes.
ऑडिबल
Yes.
सर
Yes. Yes. You're audible.
ओके सर सर 1 मिनट सर क्वेश्चन फाइंड कर लूँ
Okay. So yeah, so there is nothing much interesting to discuss for the week course content. It's like congestion control and stuff. So it's very pretty uh, scattered. So last time I discussed about sequence number and acknowledgement number, and there is TCP segments um, and bit of like scattered content is there in um, week force content. Um, I'll go to the part where like TCP connection release connection. I think I covered all these things in the last week's session. Um, Connection modeling, thin flooding, SEK flooding. Uh, yeah, I'll try to cover things such as yeah. So I'll just cover bunch of things related to TCP. Let me uh, let me open the file first.
Hello.
Yes.
Sir, weeks. Sir, how long does the week last, sir? When start and when last week of in the what duration in the week, sir? Like Monday to Friday, yeah, Monday to Sunday.
I'm not sure about that. I think the week you can check the announcement. Uh, or you can mail the NPTEL people. I'm just a tutor for this course. This administrative management stuff, it's done by the
Okay. But
yeah, the
what assignment is completed in the last week of from many how days? How
I
many days? Sorry.
I did not get the question.
Sir, weeks assignment completed from the last week from many.
You can speak in Hindi if you like.
सर वीक कब से कब तक चलता है और कब स्टार्ट होता है और कब तक लास्ट हो जाता है और उसका जो वीकेंड जो वीक होता है उसका असाइनमेंट कब तक कंप्लीट करके सबमिट करना होता है
अच्छा. So the thing is that ये सारे बातें you can ask to the NPTEL helpline. Actually, I'm not sure. I'm not the right
ओके
person to answer this question. But you can ask the NPTEL people.
ओके
They can help you with that. So they must have given you a mail ID, right? तो वहाँ पे तुम मेल कर लो तो वो मिल जाएगा.
ओके ओके सर थैंक्स
So, oh yeah, while discussing the TCP layer, so when the TCP layer now, so the packet comes from the application layer. I showed everything in the last class. This is the application layer. If you haven't seen the last class video, you can go to the YouTube and watch. I have uploaded the tutorial session as well. 2 hours. Data coming from application layer, you put TCP header. So now we'll talk about the structure of the TCP header. Okay. So TCP header, the first thing is source port. So you have to specify from which port are you sending your frame or datagram. It is 16-bit. Then destination port. Destination port is also 16-bit. Like which port are you sending? So I just um, discussed about port works and stuff. So this is the two things. So I have done that. Then come the sequence number. And this is 32-bit. So last time I discussed about sequence number, but I will tell it again. So what sequence number is that? So let's say you are sending the server to send the Google's homepage. Just sending this sentence. Okay. So this sentence will be converted to bits because computer is all 0 and 1. 0, 0, 1, 1, 0, and so on till 0, 1. Okay. And let's say this 10,000 bits. Something like that. So what you do is that you check what is the maximum size of the packet that we can send. I already mentioned in the last video again, it is 1460. Okay. So I'll just share the last video. I have uploaded it to the YouTube. Yeah, it was uploaded 3 days ago. So I will copy this. Okay. And where is the channel? Yeah, I'll paste this. If you haven't seen the video, you can go and watch the video now. Okay. Anyway, so So 10,000 bits. Okay, Google's homepage is 10,000 bits, and so this is 10,000 bits, and the maximum size you can say is 1460. Let's just round it up and say, look, no, you can say 1,000 bits. Okay, so when you are sending 1,000 bits, uh, sorry. So yeah, so if you're using 1,000 packet size or the frame size, what you need to do is that you need to chunk this data into 1,000 size packets. So this is the entire data. What you do is that you converted it to small chunks of 1,000, and so on. Okay, you take this data, you put TCP header on top. This is your data 1,000, and this is your TCP header. Okay. So what you do is that you take this TCP header. We have doubt in assignment for question number 10. Is there a doubt in the question or the answer? I will not be able to solve the answers, but I can help you with the question. Let me see the question first. Assignment 4, quiz for assignment 4. Which is the default port number for establishing HTTPD, Apache HTTP server connection? Yes, so it's asked. So as I said earlier, so there are certain ports that is reserved for there are certain ports that is reserved for certain services. So for HTTP, it is 80. For HTTPS, it is 443, I guess. HTTPS port 443. Okay. Similarly, you have to find what is the port that is reserved for HTTPD service. Okay, that's the question that is trying to ask. Okay, so TCP header. Yeah, we're in the TCP header. So in the TCP header, you put your source port, you put your destination port. Now come to sequence number. In the sequence number, you put the last byte of your data. So now last byte is 1,000. So you'll put 1,000. Similarly, the sequence number for this will be 2,000, because 1,000 plus 1,000, 2,000. Here it will be 3,000. Here it will be 4,000, and so on. So that's the sequence number. Okay, the sequence number field. There is another field. The next field is acknowledgement number. It is also 32-bit. What is an acknowledgement number? Acknowledgement number is what is the bit that you are expecting from the connection. Okay. ACK number, the bit you are expecting from the connection. If there is a connection here, so you are sending a packet, your sequence number will be 1,000. Let's say it is also sending some packet earlier. Now you are expecting it to send, let's say, sorry, okay, so let's say you are getting an acknowledgement here. Now you will acknowledge that ACK number will be 1,001. Okay, because you have already got the 1,000 packet and you want to get the packet that contains the 1,001 number. So that is the acknowledgement number. So there is the acknowledgement field is for that. Okay. So then another is header length. Header length. Okay. So header length is why header length? So I told you about the header. Here is your 1000 bit, and here is your TCP. There. So here we have a field that called options. Options. So in the options field, it is 0 to 40 byte, not bit, byte. Okay. So in the options field, you have a lot of options. You can enable it or disable it. When you enable it, your byte size will increase, right? When you disable it, your byte size will decrease. So based on which options are enabled or not enabled, the complete header size will change, right? So to keep track of that, we need to put a header length field where it will measure the length of header length field measures the length of the header. Okay, header length is done. Then there are certain flags. Okay, yeah, window size. Window size is there. I just explained what is window size. It is given 16 bits. So it is given 16 bits, and there are some flags as well. Like there is urgent flag, there is SYN flag, there is ACK flag, and there is TTL flag. Not TTL, I guess. It's fin flag. That fin flag. Fin flag. PSS flag. H and RST. So I have already discussed the SYN flag and ACK flag in the last tutorial. Already discussed. Now come to the urge flag. So urge flag is urgent flag. Urgent flag. Okay. So okay. So let me give me 2-3 minutes. I'll discuss all these things after 2 minutes. uh, sorry. Anyway, so the urgent flag. In the urgent flag, so what you do is that sometime we need. So there are some. There is your server, and there are some packets. It is going. Okay. But there is some certain, like, in the Windows. So in the server there will be a window, right? Buffer. So all these packets are P1, P2, PN are waiting in the line to be processed. Let's say your packet is very important. So what you do is that you put urgent flag to 1. So urgent flag is set, or urgent flag is set as true. 1 is true. So what will happen is that it will push your packet to the front and will be processed by the server first. That's the work of urgent flag. Then what flag is there? Then fin flag. Yeah, fin flag I have already discussed in the last video. Go to the video and watch. I'll not discuss it again. Urgent flag is done. Then PSS flag and RST flag. Okay. Let me discuss the PSS flag and the RST flag. PSS is push flag. Okay, and RST is reset flag. Uh, 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 uh. What is this flag thing? Okay. Reset flag is used to reset the connection. Okay. So so finish flag is used to finish the connection, but reset flag is used to reset the connection. Suppose the connection is going on between two client and server, reset flag is used to reset the connection. So you have to start the connection again. That is reset flag. So there is something called push flag, PSH flag. So it is push flag. So as I said, your data is collected into small chunks, thousand, and so on. Let's say the message you want to send or data you want to send is less than 10,000. So data is less than 1,000 bits or bytes. Okay, let me erase this. Byte. The data is less than 1,000 bytes. So what it will happen? What will happen? So it will wait till 1,000 bit is filled. Then bit is get filled. Then it will send to the next layer. So what happens is that in a interactive application, let's say you are using WhatsApp, okay, and your friend is sending some message and you are sending some message, okay. So what happens is that as long as your friend types something and send, it will be displayed in your system. Let's say if this data is less than let's say some 1,000 byte, and according to this, if 1,000 byte is not complete, it will not send. So what happens is that your friend has to write 3-4 messages before it will display to you, right? So to avoid this, what you do is that in an interactive setting, what you do is that we set the PSH flag to 1. 1. 1. So when you do this, what happens is that even if the data size is less than 1,000, let's say it's 100, it will be pushed to the next layer. I mean, you'll put a header on top, header and push the data to the next layer, and it will be processed and go to the destination, and so on. It will not wait for the entire data byte to come. So that's where we use the PSH flag. Okay. Apart from these fields, there are one or two more fields, I guess, in the TCP header. One is checksum. So checksum is just the sum of all the values. Okay. Where is the header? So there is something called checksum. The checksum is like, take all this value, source port and all these things, take all these things, then make a sum and make a hash and put it here, checksum. So why checksum is used? So checksum is used when if you change the destination port to something else, like it was 11 and you change it to, let's say, 27, the checksum will change. So in the receiver end, it will calculate the checksum again. So checksum at the receiver end will be calculated, and it has to be same as checksum on the header. Okay. So if checksum as a header is not equal to checksum at the receiver end, then packet is compromised. Okay. I mean, someone has messed with the packet. That's why we use checksum. And apart from that, there is window size and there is urgent pointer to point which byte is urgent among all the byte. So I said, you put urgent and it will be pushed to the front. Okay. So, but this P have 1,000 byte. Maybe out of the 1,000, only 500 is urgent to be sent, other is not. So the pointer will point at that, okay, this is the person is urgent. To process this person first and process the rest of the thing later. Okay, so that is the use of urgent flag. Checksum I explained, and there apart from that there is options, and other the rest of the things are data. All these things are data. It's a basic typical TCP header thing. So yeah. So this is a discussion about TCP headers. So I'll stop the discussion for this week because this week's content is a bit here and there. We'll start with network layer next week. Before starting network layer, I'll try to summarize all things. But before summarizing all things and moving forward with the discussion and in the subsequent weeks, so I just wanted to ask you guys, like, what do you want? So should I? So there are three ways we can do this tutorial. One is discuss your doubts. That is option one. Second is discuss uh, a topic of my choice, because we cannot discuss everything in the 2-hour session, and it's barely 1.5-hour session now, I guess. So you can just discuss some of the things that I thought it is important to discuss and picked from the text or the syllabus. We can discuss that. Third, we can discuss content around the assignment. So, so let's say there are 10 assignment questions and it is covering, let's say, 5 concepts. So what I will do is that I will discuss those concepts which will be helpful for solving your assignments. So which one do you want me to do in the subsequent lessons? Like, discuss your doubts or because you don't have any doubts. Yeah, okay. So you're saying 1 and 3. So I should discuss your doubts first, then go and discuss the concepts around the assignment, which will help you to solve the assignment. Actually, the thing is that I was expecting that you must have went through the assignment and you will be asked doubt across the assignment so that I can cover all this topic. Now I haven't gone through the assignment as well. So now you are not asking questions and I am not asking, so you're not asking questions and I am not able to answer them. So it's a bit thing. Okay. Assignment 4, which of the following statement is are correct concerning the TCP acknowledgement? Okay, someone asked, he's confused in the options of question 1 and 2 and assignment 4. Question number 1 is, which of the following statement is are correct concerning the TCP acknowledgement number? It is a 16-bit number. It contains the sequence number of the previous byte the receiver has received. I discussed it already in my discussion today. That is it a 16-bit number? Acknowledgement number is 16-bit number. It's a 32-bit number. Okay. It's a 32-bit number. Okay. And what is the next question? I discussed today that thing already. Even if you haven't asked that, I have discussed that. And it contains the sequence of the previous byte of the bytes the receiver has received. If you see here, the previous byte was 1000. But what is the acknowledgement number? 1001. Is it containing the sequence number of the previous byte of the receiver that has received, or it is containing the byte it is expecting? So it is containing the byte that is expecting. I shouldn't be saying the answers, but yeah. So this is the discussion that we had. So based on this, you can choose your answer. Second question is, if the maximum network layer payload size is 2 KB, what is the maximum TCP payload size? So 2 KB is, I'll clarify the question. So 2 KB is equals to 1024 into 2 equals to 2048 byte. So it is saying that you are getting a packet from application layer, okay, and you're putting a TCP header on top, and you're passing it to network layer. Then you are putting this TCP layer, and you're putting a IP header on top. Okay. So what it is saying is that it is saying the maximum network layer payload size is 2 KB. Okay, what is the TCP payload size? That means it is saying the IP header is applied. So here, so this should be 2 KB equals to 2048 byte. Now the question is, what should be? So if this is 2 KB, yeah, this entire thing is 2 KB. I mean, you're passing this thing here, right? This is 2 KB. So now it is asking, what is this? What is this size? TCP layer payload. So two things. Application layers entire data is TCP layers payload, and this is there are two things in each layer. There is payload plus header. Okay. So application layers entire data is this is payload, and this has a TCP header. Entire thing is payload here, and it has a IP header. So it is asking what is this size? The answer would be so this is 2048. So this is 2048 already given. So 2048 minus this TCP header size. That will be this one, right? So TCP header size. This will be the answer. You solve this, you'll get the answer. This is a clarification of the question. Anyway, so I'll be discussing in that way. So another thing I was also wanted to ask you guys is that if I upload the uh, solution of the assignment questions, like once the assignment questions answers are released, so they are just releasing the answers, right? Um, or they are giving the solution. Yeah, they're giving some solutions, but if I solve these questions and give the solutions as a video, will you be watching it or not? Like, will that be helpful for you, or is it not helpful for you guys? Just answers. Okay, it will be helpful. Aniket is saying just okay. So if I just so see, I'll not be able to send the answers before it is released because it is against our policy. But after it is released, I can release the solutions. Okay, so that's why I was asking. Anyway, so I'll do that same thing. But for tonight, I think we'll close the session today now. It is a short session. But yeah, so we'll close the session now. I'll see you all guys next week. Thank you. Please subscribe the channel. Anyone who is going, subscribe the channel. I've already shared the channel link. Go and subscribe the channel. I will be uploading this. So because yeah, so the link I was say so the reason you are getting this videos is because I'm sharing the links to the NPTEL seat that they provided. But the solution that I will be releasing in the weeks, I'll not be able to provide the link somewhere. So that's why you just subscribe to the channel so that you will get that notification when you uh, hit enter. I'll close the meeting now. Thank you everyone for joining. I will meet next week.